Going to put on the recording. Welcome to everybody who's just joining us. It is now about 12 o'clock noon. I am going to put up the screen over here. I'm going to put up my main monitor here. All right. Okay. Okay. There we go. Welcome to everybody. My name is Shlomo Haas, and welcome to a Coopersmith webinar for the math class. Now, I see there are a couple of people in here, so welcome to those of you who are here now. If you have any questions, you can go ahead and type them into the chat box. Right now, the chat box is empty, but I'm going to put something in here. I just said chat here, so you can see where the chat box is. If you have a question, please type something into there. In fact, maybe I'll even put this over here so I can see it at the same time that I'm talking. So the purpose of this class is to go through some of the material for algebra and some of the math courses that we have over here. Obviously, if anybody has any questions, please feel free to chime in and to ask them. And what I am going to do first is quickly go over some of the algebra material, and then I want to focus on some things that are covered on the exam. And again, for those of you just joining us, if you have any questions, please feel free to chime in and just click over here on the chat box over here. You should have a little GoToMeeting thing that looks something like this, and over here is the chat. You're not going to be able to do it on my screen over here, but on your own little box over there, you should be able to press the chat window. Okay, so there are 15 different sections over here for the algebra course. Now, there is a full video course. This is almost 6 hours long, this video, that is designed to really be the course from start to finish. If you watch that entire thing and you know how to do everything on those materials, you will basically get 100 or something close to 100 on the exam. So that's one option you have. The other thing you can do, which I also recommend, is to go through the individual 15 lessons. So over here, there are 15 slides, PowerPoints that are focused on the 15 different lessons over here. They have different titles, obviously. Each of them cover various things. Now, you're probably not going to learn how to do things specifically from this, these slides over here. If you go, for example, if you didn't know anything about quadratic equations, excuse me, where were we? Yeah. If you didn't know anything about quadratic equations and you just looked at this, you're probably not going to learn how to do them directly from this. But if you know them already and you want to review them, or you've watched the video, or you want to watch the video a little bit later on and you want to go through these, certainly these can help, and I think these can be an excellent way to review the material, even if not necessarily to learn it from scratch. Then we have, of course, the homework and practice homeworks and answer keys. We've got for each of these 15 different sections, we've got a practice homework. Many of these questions are harder questions than you're going to find on the actual exam. I'm not going to, for example, if you look over here in the let's see, where's this one? On homework number 4, on solving linear equations, if you had a chance to look at this, we have a whole bunch of these. We have a whole bunch of these questions over here, and a question like this, number 3, which is an enormously complicated question. We're not going to give you something quite this hard on an exam. I gave you this in the homework just so you can practice on it. But the questions that you're going to see on the exam are probably more comparable to something like this, or to something like a word problem like this, than the most complex problems, but the problems will be comparable to the ones on the homework. I will tell you this, if you can do every question on the homework, you'll do very well on the exam, because obviously while the exam questions are not the exact same questions as they are on the homework, they're pretty similar. They're the sorts of things that are pretty much the same, with the exception of that they have different numbers. Okay, there are answer keys, of course, over here for all of them. There's one, it's in one big file, so you'd have to kind of go through them. One second. All right. And then we also have a review videos. The review videos go through the homeworks from start to finish. There are 15 homeworks altogether, and some of them are in multiple parts, for example. Homework number 1, there are 4 parts that go through it. Homework number 2, there are also 4 parts. Homework number 3, there's 1 part. So that's really kind of the schedule. What I would do, the first thing I would do if I were studying for this exam, the first thing I would do is to go over the Algebra full course video, which, again, it's a fairly long video. But if this is the way it looks. It starts like this, and it goes all together about almost about 5.5 hours long, give or take. It goes through pretty much how to do everything. I would not necessarily worry about the syllabus. The syllabus goes through all these things and practice homeworks. You don't necessarily have to worry about that, and the reason why you don't have to worry about that is because we actually gave you the homeworks. You don't have to buy this textbook necessarily, because the homeworks are all, rather than actually having you go out and buy the book and doing the homeworks on the paper and all that, we just actually gave you the homeworks over here. Now, these homeworks are optional. You do not have to do any of the homeworks, and nobody will ever know whether you actually did any of the homeworks, but it is a very, very good way to practice for the exam. Okay, and again, just a reminder, if anybody has any questions, please feel free to chime in, or if there are any other issues I can help you with. All right. So the first thing is to watch the video. The second thing I would do is to go through the slides, to make sure that you know the materials in these slides. If you know everything on the video, then you'll know everything in the slides anyway. It won't be that complicated. And then to go through the homeworks, to do the homeworks, and then you can test yourself on the answer keys, and if you're not sure about something, you can watch the review videos. If you do all of that and you basically understand what's going on, you will do very well on the exam. I can't guarantee you're not going to make a mathematical mistake on the exam, but let's put it this way. If you know everything on the homeworks, you'll get in the 90s on the exam. Again, I think that's pretty clear. Okay. So next, what I wanted to do is I wanted to go over some specific types of questions that may appear on the exam, and I want to go through how to do them, and just to go through some areas where I think people tend to lose points for no real good reason, just because of mistakes. And I want to kind of just indicate the sorts of mistakes that people sometimes make, and so the sorts of things to watch out for. Okay, I've got this, which I'm going to resize over here. Now, I've got one type of question over here that appears on many versions of the exam. I think there are 5 versions of the exam that are floating around out there, and 4 of them have a question like this. So if you take this exam, there's an 80% chance that you're getting a question like this. And I see that people make mistakes and very often lose a bunch of points in this kind of question. It is in the homework, it is in the video, it is, but it does seem to be the sort of thing that many people struggle with. Let's say I take something like this. Let me make it a little thicker so it's a little bit easier to see. Okay, let's say I say something like y to the 3rd minus 27, and I say to factor this completely. Now, factoring in general, let's put this aside for a minute, and let's take an easier type of factoring. Let's say I take something like this. Again, hopefully you should know this already. If you don't, that's okay. Let's say I take something like this. X squared plus 5x plus 6, and I ask you to factor this. Now, the way to factor any trinomial, the way to factor any 3-part number over here, is to factor it into 2 binomials, 2 double numbers over here. So, for example, in this case, when you have, this is basically high school stuff. If you have three terms over here and you want to break that down into 2 binomials, what you would do is the first 2 numbers would be numbers that multiply up to whatever your first term is over here, and the only 2 terms that get you up to x squared that can be in this sort of a problem are x and x. And then the way you would figure out the other 2 numbers is if this number is a positive, then the 2 numbers have to be the same. And the reason is because the last 2 numbers, whatever is over here and whatever is over here, have to multiply up to this number. Which means that if this is a positive number, these 2 numbers both have to be positive or both have to be negative. And the reason is because multiplying up to a positive, 2 positive numbers multiply up to a positive, and 2 negative numbers multiply up to a positive. A positive and a negative number multiply up to a negative. So which means if this is positive, both of these numbers, both of these signs, whatever these two signs are, have to be the same. If you get a question like that, where the two numbers have to be the same, the two signs have to be the same, then what you need to do is you need to look at this middle sign. If this is positive, so they both are positive or both are negative, and then you look at this sign over here. If this is positive, then they both have to be positive, and if this is negative, they both have to be negative. So in this case, both of these signs have to be positive for the simple reason that they have to multiply up to a positive, and the middle number, which is the sum of these two numbers, also is positive, so these both have to be positive. Now, in order to figure out what these numbers are, you're going to have to figure out two numbers that multiply up to this number and add up to this number. And by the way, when I say add, I mean add and or subtract. Those are essentially the same thing. In this case, it's fairly easy. There's really only two possibilities of things that can multiply up to 6, which is 6 and 1 or 3 and 2. Those are the only two possibilities. Obviously it could be 2 and 3 or 1 and 6, but either way they have to add up to 5, and the only of these combinations that add up to 5 are 3 and 2. So that's how we get a very simple factoring problem like this. And then if you wanted to check yourself to make sure you had the right answer, you'd multiply it out. X times x, which is x squared, then the outer x times 2, which is plus 2x, then the inner, which is plus 3x, plus the last, which is 6. And then these two combine, and you get this, which of course is the same as up here. Again, I hope everybody already has a basic understanding of this. If you don't, then obviously you need to watch the videos. This is a fairly elementary component of this course. But I wanted to get to something that was kind of comparable, and that is something like this: y to the third minus 27. Now this is an example of a cube, and it's the sort of thing where all of the intermediate terms were wiped out. You have only the very first term, y cubed, and then you have minus 27 at the end. When you have a scenario like this, it's kind of a scenario where all the middle terms cancel each other out, and the only thing you have are a monomial and a binomial, which means 2 terms, and a trinomial, which means 3 terms. To do something like this, the first thing you need to do is ignore and realize you're going to have 2 terms over here. I'll put term 1 and term 2 over here. You're going to have 3 terms in this one. The 2 terms are going to start with whatever the root of this is. In other words, if this is y to the second, this will have to be y over here. And whatever's over here will have to be whatever this number is, the cube root of whatever that number is. In other words, that number, whatever this number is, that number cubed has to give you this number. So over here, this has to be a perfect cube, by the way. There's only a limited number of numbers you can get over here. You can get 8 because 8 is 2 to the third power. You can get 27 because let's write them out as a matter of fact. It has to be something that's a perfect cube. So it could be 1 to the third power, which is 1. It could be 2 to the third power, which is 8. It could be 3 to the third power, which is 27. It could be 4 to the third power, which is 64. It could be 5 to the third power, which is 125. It could be 6 to the third power, which is 216. And let's leave it at that. I think 7 to the third power is 343. But it has to be one of these numbers. The only way you can get a question like this is if it's one of these numbers over here. So here we have the 27, which is 3 to the third power. So you're going to have a 3 over here. Then you kind of have to remember, although it is fairly obvious once you do it a few times, on this side, this number, in other words, the first spot, is going to be that same term, that same letter, to the second power, y to the second power. And the reason for that is because the first terms have to multiply up to this number over here, to y to the third power. So if you have y over here, and you have y to the second over here, y times y to the second equals y to the third power. The middle term over here is going to have to be this number, whatever this number is, times y, or times whatever the term is, so it's 3y, and the last term is going to be this number times itself, which is going to be 9. Again, it's a little bit of memorization over here, but just try to do it a few times and you'll kind of recognize the patterns. And everything is pretty much going to cancel out eventually, as we'll see a little bit later on. All right. Now, the next question is, it's again, just to reiterate, the first two numbers are going to have to multiply up to this number. The last two numbers, 3 and 9, are going to have to multiply up to this number. So if this is negative 27, that tells you right away that this sign and this sign have to be opposites from each other. Sorry, did somebody have a question here? No, not yet. Okay. This sign and this sign have to be opposites from each other. So, I'm sorry, just give me 1 second if you don't mind. Somebody just came in. All right, I'm sorry. I hope nobody. I just have to go out for 1 second. I'll be back in about 1 minute. I hope nobody minds. Sorry about that. All right, we're back. Sorry. Okay, fine. Okay, where was I? Yeah. Okay, so these signs have to be different from each other. The y, because the last term over here, the 3 and the 9 have to multiply up to the 27, and because this is a negative, these two have to be opposite from each other. So if this is a negative, what you simply need to do is make this into a negative and make the other two signs pluses. So if you do that, then that's really the entire answer. The first sign has to be negative. The sign in the trinomial, in the big term, both signs have to be positive. If this were a positive, by the way, let's take another similar problem. Let's take x to the third power plus 64. The answer would be essentially the same. You'd have x over here and x squared over here. The middle term again, this term over here would be 4 because 64, the third root of 64 is 4. The middle term would be 4x, and the last term would be 16. Again, 16 is just 4 times 4. Instead of the terms being minus plus plus, the terms would be minus minus plus. I'm sorry, actually, they would be plus minus plus. There we go. Okay. Yeah. So let's make sure let's multiply them out and just see why that is. Let's see, for example, in this example over here. Let's say we multiplied all of these out. Y times y to the second is y to the third power. Then we multiply this times this. And again, just when you multiply two factors, you have two terms, you have to multiply everything by everything. So y times y to the third is plus y times 3y is 3y to the second, y times positive 9 is plus 9y, and then we have to multiply the 3 by everything else. Negative 3 times y squared is negative 3y squared, negative 3 times positive 3y is negative 9y, and then the last term is negative 3 times positive 9, which is negative 27. When we have something like this, it looks pretty complicated, but then you realize right away that everything pretty much cancels itself out. The 3y squared cancels out with the negative 3y squared. Positive 3y squared, negative 3y squared. Then you've got positive 9y minus 9y. And the only thing you have left is the y to the third power minus 27. Okay, when you have something like this, you have x to the third power and then negative 4x squared positive then x times positive 16x, and then the second term, when you do the 4, you do plus 4 times x squared is positive 4x squared, and then plus 4 times negative 4x is negative 16x, and then plus 4 times 16 is positive 64, and again you have the same phenomenon. The negative 4x squared and the positive 4x squared cancel. The positive 16x and the negative 16x cancel, and in the end you're left with x to the third power plus 64. These two problems are essentially the same problems, except that the only difference is where you put the plus minus. If this is a negative, well then it's a negative over here and a positive on the other one. If this is a positive, then it's a positive over here and a negative and a positive in the other one. Again, I just wanted to do this and make it clear because this does appear on many versions of the exam, and it is the sort of thing that many people do struggle with at various times. All right, let's take a look at some other examples. And again, if anybody has any questions, please feel free to chime into the chat window over here. All right. Okay. I'm going to do another relatively simple question that some people struggle with. Let's say I tell you that after a 25% discount, a refrigerator costs $200, and then I ask you for the original price. I apologize for my handwriting being a little sloppy, not that easy to write with these tablets over here. But anyway, so we have a 25% discount. A refrigerator costs $200. What is its original price? Now, first of all, you can probably figure this out using your head. But let's assume that you don't want to figure it out using your head. That's perfectly okay. You really shouldn't need to figure this out using your head. Whenever you get a percentage problem, there are three elements of it. There is the rate. The rate means the thing that precedes the percentage mark. That's what the rate is. An interest rate is 2%. Pass rate is 90%. Whatever it is. Those things are all rates. Then you have the B for the base, and then you have the P for the percent representation. Again, different people can call it different things. It doesn't really matter. I like to call them R, B, and P. R for the rate, B for the base. The base means the whole number. In this case, the base would be the original price, and the P would be the percent representation, which means the number that corresponds to the rate. So, the simple mathematical formula to figure out any percentage problem is simply the rate times the base equals the percent representation. So, if I tell you that in this case, what is the rate? The rate is 25%. Which is the same thing as 0.25. That's what percentage means. The base is the whole number, the thing that we are out of, and in this case, we really don't know what it would be the original price. The base would be the original price. And the percent representation would be the number that we are looking at over here. Now, the refrigerator in this case costs $200. So if we figured that out, if we, for example, said the rate, which is 25%, which is 0.25, times the base, which we don't know what it is, so we'll just leave it at B. Actually, no, that wouldn't. You see, the problem is I was looking for the discount over here. Okay, so right, so the discount here would actually be, right, that's at, right, what is the amount that you're actually paying, the rate, well, what does the 200 correspond to? See, that's a mistake that I made. The amount that you actually are paying, the $200 is not 25%. The 25% is after $200 is after a 25% discount. So the rate is actually 75%. I think that's probably what confuses a lot of people that are doing these kinds of problems. The 25% is just the discount. After the discount, the refrigerator costs $200. Because of that, the rate is 75% because the $200 is 75% of the original price because the discount was 25%. So the formula would actually be 0.75 times 200, times the base, equals 200. And so then in order to solve for the base, you would simply divide each side, isolate just like you would do with any other equation, isolate the b by dividing each side by 0.75. And you could say the b is 200 divided by 0.75, and again, you can do this on a calculator, let's say. Let's say we got 200 divided by 0.75, and our answer would be $266.66. The point is that when you get a problem like this, always figure out what do your numbers correspond to. This formula is very simple. The easy part is applying the formula. The hard part is figuring out what they correspond to. A 25% discount. Let's say I told you, for example, what the discount was. What if I told you something like this? What if I told you a 40% discount saves you $120. What is the price? Well, here again, let's define the three terms. We want to define the R, define the B, and define the percentage representation. In other words, the number that corresponds to the percentage. Here, the $120 corresponds to the 40% because that is the discount. The discount is something that saves you. So our rate is 40%. The base, we don't know what it is because that's the price. That's the thing that's the entire amount. And the percentage representation is $120. So here we could apply the same formula. The rate times the base equals the percentage representation. The rate is 0.4, the base we don't know, and the percent representation is 120. Here, again, to isolate the base, we would do divided by 0.4 divided by 0.4. And if you do 120 divided by 0.4, I believe you should get 300, but let's do it just to make sure. 120 divided by 0.4, and we get 300. So the price of the entire thing was 300. Sometimes you might be given the base. Let's take another example. Let's say, something's being sold, whatever it is, doesn't matter what it is, for a 30% discount, and the original price was $500. What's the sale price? And we want to know what is the sale price. Well, again, let's take our three steps. Any of these problems can be solved by this method. The rate, the base, and the percentage representation. The rate, we're told, is 30%. Okay. The base is the original price. It's what the whole thing is based on. So that's 500. And now we don't know what this is. So we can use the same formula. Rate times the base equals the P. Okay. The rate is 0.3 or 0.30, which is the same thing as 0.3. The base is 500 equals the P. 0.3 times 500 is 150. Again, you could do it on a calculator or you could just do it in your head. Just to make sure, I'll do it on a calculator, although I'm sure that's the correct answer. 0.3 times 150. And I'm sorry, I did it wrong. 3 times 500. Okay, 150. Now, once we have this, once we have the 150, is that our answer? Is that the sale price? No, it's not quite our answer yet. Because what is the 150? What does the 150 represent? The answer is the 150 represents the discount. That's the 30% discount, and it was 30% of this, which is our 30% discount. So if the original price was 500 and our discount was 150, that means the sale price is 500 minus 150, which is $350. Okay, let us take a look at some other ones over here. Another one that people struggle with. I am going to put something like this. Let's say I tell you y squared plus 7x equals 30. I'm sorry, this can't be. Let's 7y equals 30. And your question is, figure out what y is. Okay. This is a classic quadratic equation. Now, the first way to solve a quadratic equation is to set the whole thing equal to 0. Get rid of the 30 from this side. So I'm going to subtract 30 from this side because that makes this side 0. And once I do it from this side, I have to do it to this side too. 30 doesn't combine with either of these terms. So what we have left is y squared plus 7x minus 30 equals 0. This is now in the correct form. Now, there are really 3 ways that are covered in the course in terms of how to solve them. The easiest way to solve it, and the one that you should do if it works, is to try to factor. In this case, I believe it is going to factor. We discussed this a little while ago. It's going to take 2 binomials. And the first is going to be y and y, because y and y multiply up to y squared. Now, unlike before, when this was a positive, so the terms were the same, here it's a negative, so the terms are different. So one of them is going to be a positive, and the other is going to be a negative. What we need to figure out are 2 numbers that multiply up to 30, that's the last number, and add up to whatever this number, which happens to be positive 7. If you look at the roots, the factors of 30, you can have 30 and 1, you can have 5 and 6, you can have 10 and 3, and I think that's pretty much it. It may take a little trial and error. If you're not as familiar with it, it might take you a couple of minutes to think about what the roots of 30, what multiplies up to 30. But which of these adds up to 7? Well, the answer is 10 and 3. Remember, adding and subtracting is the exact same thing. So therefore, if this is a negative, and you make this into a negative 3, and this into a positive 10, then this will work, because 10 times negative 3 is negative 30, whereas 10 minus 3 is positive 7. Once you have this, then simply break them up and say each side is equal to 0. Because if this is equal to 0, the whole thing is 0, and if this is equal to 0, the whole thing is 0. So you have y plus 10 equals 0, and y minus 3 equals 0. So in this case, subtract 10 from each side, and you have y equals negative 10. And on this side, add 3 to each side, and you've got y equals 3. And both of these are the correct answer. If we plug them back into the original, they'll both work. If we do what was the original? The original was y squared plus 7y equals 30. Let's do negative 10 first. Negative 10 squared plus 7 times negative 10 equals 30. Negative 10 times negative 10 is positive 100. 7 times negative 10 is negative 70 equals 30, which of course is correct. And if we do it with 3, it will also work. Y squared plus 7y equals 30. So that's 3 squared plus 7 times 3 equals 30. 3 squared is 9 plus 7 times 3, which is 21, equals 30. And of course, that is correct as well. If you cannot factor, sometimes you just simply can't factor for whatever reason, it just doesn't work. I'll give you an example of something that doesn't work. Let's say I've got x squared plus 4x plus 1 equals 0. Now, this is simply not going to work. There's no way to factor this. The only thing that multiplies up to 4 is either 2 and 2 or 4 and 1, and neither of them are going to add up to 4. I'm sorry. The only thing that multiplies up to 1 is 1 and 1, and 1 and 1 don't add up to 4. So there are two ways to do this. Number one is to use the quadratic formula. Quadratic formula will work no matter what quadratic equation you have. Even if it's something that would have factored, the quadratic formula will work. The downside to the quadratic formula is you have to memorize it, which you should anyway, but the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a, with a being whatever's next to the x, b being the x squared, b is whatever is next to the x, and c is whatever the number at the end is. So in this case, a is whatever is next to the x squared, which is nothing, so it defaults to 1. B is whatever's next to the x, which is 4, and c is whatever's over here, which is 1. So we can multiply it out. We can say x equals negative b, which is negative 4, plus or minus the square root of b squared, which is 4 times 4, which is 16, minus 4 times a, which is 1, times c, which is 1, so which is 4 altogether. 4 times 1 is 4, divided by 2, which tells you that x equals negative 4 plus or minus the square root of 12 divided by 2. And this is leaving it like this would be okay. There's, if you wanted to break it down further, you could break down the negative 4 plus or minus the square root of 12 is actually the same thing as the square root of 3 times the square root of 4, because 3 times 4 is 12. And so we'll say, and the square root of 4 is 2. Again, this is covered in the section of how to break down roots. So we could say, for example, this is 2 times the square root of 3 divided by 2. And then you can divide each side by 2 to get rid of the denominator, and what you would end up with is negative 2 plus or minus the square root of 3. Again, the reason for that is you would divide this by 2 and this by 2 in order to get rid of the denominator. You can do that as long as you do both sides by that. And so negative 4 becomes negative 2, and 2 times the square root of 3 simply becomes the square root of 3. There are really two answers here. There's always two answers in a quadratic equation. One of them is 2 plus the square root of 3, and the other is 2 minus the square root of 3. So the square root of 3 is about 1.67 or something like that. So one answer is going to be about 3.67, and the other answer is going to be about 0.3 something. So that's one way of doing it. The other way is the method called completing the square, which is a little harder to execute, but it's a lot simpler and faster to do once you know how to execute it. Completing the square simply means, it only works, by the way, if this is a positive number. If this is a negative number, you cannot complete the square. Completing the square means taking whatever this is, halving it, in other words, breaking it up into 2, and squaring that half and making sure that goes over here. In English, what that means is we take half of 4, which is 2, square it, 2 squared is 4, and we want a 4 to go over here. Once we do that, you'll see it becomes a lot easier to solve the problem. So how do we make this into a 4? Well, that's easy. Remember, when you're talking about algebra, you can do anything you like to one side as long as you do the exact same thing to the other. So in order to make this into a 4, we simply have to add 3. And if we add 3 to this side, we could add 3 to that side. That's all we want to do is make this into a 4, because half of this squared is 4. Let's say, for example, if the number was x squared plus, let's say, 8x plus 1 equals 0, well then we would take half of the 8, which is 4, and square it and make that into a 16. So here we'd want to add 15 to each side to make this into half of this number squared. But in this case, back to this case, we would say x squared plus 4x plus 4 equals 3 now. And here we can complete the square because this breaks down into x plus 2 times x plus 2. That's what this will accomplish. If you have half of this number squared over here, that means that these two binomials will be the same. In this case, for example, just to give you another parallel example, we had this. Well, this breaks down, again, into x and x, plus and plus, because this was positive and this was positive. What two numbers multiply up to 16 and add up to 8? Well, the answer, of course, is 4 and 4. So anytime, whenever you complete the square properly, let's say for another example, let's say I had y squared minus 6x plus 5 equals 0, and I wanted to complete the square. No problem. Take half of that, half of negative 6, which is negative 3, multiply it by, let me make this separate areas. We'll solve them all. I want to multiply this by, square the negative 3, and you'd get positive 9. If this were a positive 9, it would work as well. How do we get this into a positive 9? No problem. Just add 4 to this side, and of course you got to add 4 to that side, and you get y squared minus 6x plus 9 equals 4. And this also does the same thing. If we factor this, we'd get yy. What two numbers multiply up to positive 9 and add up to negative 6? The answer is negative 3 and negative 3. It's a negative and a negative because this is a positive and this is a negative. So 3 times 3, negative 3 times negative 3 is positive 9, whereas negative 3 minus 3 is negative 6. Either way, we can now convert these, where we had x plus 2 times x plus 2, we can convert that into x plus 2 squared. Over here, we can convert this into y minus 3 squared. Again, y minus 3 times y minus 3 is the same thing as y minus 3 squared. A number squared is always something times itself. Over here, we'd have x plus 4 squared. In all of these cases, the next step is simply to take the square root of each side, because that gets rid of the squared. Square root of x plus 2 squared, simply x plus 2, equals square root of 3. Over here, take the square root of each side. Then you get x plus 4, because the square root of x plus 4 squared is x plus 4, equals square root of 15. Over here, same thing. Square root of y minus 3 squared is y minus 3 equals square root of 4. Let's solve them all one by one. Well, over here, it's easy. Just subtract 2 from each side, and what you have is x equals the square root of 3 minus 2. And if you notice, of course, that's the same answer as we got over here. Over here, we got negative 2 plus or minus the square root of 3. But first of all, so the negative 2 is the same as the negative 2. And then plus or minus the square root of 3. A square root, by definition, is always plus or minus, because a positive and a negative number multiply. Let's say, for example, positive 4 squared is 16 and negative 4 squared is 16. Positive 10 squared is 100 and negative 10 squared is 100. Whenever you're talking about squared, there's no difference whether the base number is positive or negative. So this is inherently plus or minus, so we got the same number. Over here, we'd subtract 4 from each side, and we'd get x equals the square root of 15 minus 4, which is our answer. If we did it this way, we'd get the same number. Over here, what about this, by the way? Over here, we had y, let's say equals, let's say we added 3 to each, the square root of 4 plus 3. Here we can break it down, because 4 is actually a perfect square. So now, of course, the square root of 4 could be positive 2, or the square root of 2 can be negative 2. So y equals positive 2 plus 3, and y equals negative 2 plus 3, which means y equals positive 5 and y equals positive 1. And both of these are the correct answers. We have 2 answers for everything. We've got, positive the square root of 3 minus 2 and negative the square root of 3 minus 2, which is the same thing. So there's 2 answers no matter what we do. if you get whole numbers like this, if you get perfect squares like this, that means that you could have factored it originally. But again, this method will work for every kind of, will work as long as the middle term over here is an even term. I'm sorry, I said positive up here. I meant even term. It won't work if this thing isn't. It won't work if this thing is an odd term. All right. Let us see what other issues there are. Okay. Let's take another example of something that people tend to struggle with, and it's a very easy question, but people just seem to get it wrong, not because they're not able to do it, but they're just not sure what the question means. Let's say I say, find the domain of, let's say, x 1 over x plus 3 minus 7 over x minus 2, whatever it is. And I ask you, find the domain of that. So some people take a look at this and feel they have to solve it. Of course, it's impossible to solve, and because there's no equal sign. In order for something to be solvable, there has to be an equal sign. There has to be an equation over here. The domain simply is, what can x be? Normally, what is the domain of x? Domain of x is infinite. If I say x, what is x? Well, we don't know what x is. X could be 1, it could be -1, it could be a million, it could be a billion, it could be a trillion, it could be -1 trillion, it could be -a quadrillion. There is no indication. If I wanted to say what is the domain of x, what I would say is it's somewhere between -infinity and +infinity. That's the sideways 8 means infinity. It could be anything. It could be absolutely anything. Now, in terms of something like this, the only thing we know about x is we know that a denominator cannot be 0. So what does that tell us about x? Doesn't mean x can't be 0. X can be 0. It's just that neither denominator can be 0. This tells us that x can't be -3. Why? Because if x were -3, then this denominator would be 0. This tells us that x can't be 2 for the same reason. If x were 2, then this denominator would be 0. So what I would write is x, so that x is not equal to -3, and x is not equal to 2, and you could put a little bracket over there, and this would be a good answer. If you just wrote the answer is x can be anything but -3 or 2, still a full credit answer. It's fine, because that's what it is. That is the actual answer. That's one type of question you might get in terms of the domains. Another type of question you might get is one that has a square root. So let's say I ask you to find the domain of square root of x minus 3. One thing we know about square roots is they cannot be negative. If square roots are negative, that's called an imaginary number, because if you think about it, let's say we have got the square root of -16, there is no number that this can be. It can't be +4 because +4 times +4 is +16. It can't be -4 because -4 times -4 is also +16. A negative squared is always a positive. So there's no such thing as a square root of a negative number. So, I mean, it's an imaginary number which can be used in some circumstances, but for our purposes, it cannot occur. So what does that tell us about x? We have to make sure that x is big enough so that the domain is that whatever's inside the square root has to be positive. What does that mean? X has to be 3 or greater. If x is 2, then the square root's going to be negative. If x is 1, the square root's negative. If x is 0, the square root's negative. If x is negative, for sure the square root's negative. So what I would say, the way I would write this, is that x is greater than or equal to 3. Remember, it can be equal. It's fine for a square root of 0. You know, square root of 0 works. Square root of 0 is simply 0. So if x is 0, that's fine. I'm sorry, if x is 3, that's fine. It would be the square root of 3 minus 3, which is the square root of 0, which is 0. X can be 3, x can be 4, x can be 5, x can be 6, but it cannot be less than 3. So if you told me, if you just wrote on your test, x is greater than or equal to 3, that's fine. It's a full credit. Greater than or equal to 3, that's fine. If you wrote this, by the way, if you wrote x is greater than 3, that's not a full credit answer. You know, maybe that's, you know, a -1 or something like that, because you basically got the idea, but you missed the fact that x can be equal to 3. You know, if you write in English, x must be equal or greater than 3, that is a correct answer as well. Again, I don't need it necessarily in mathematical terms. If you want to write it in English, as long as you convey the idea, that's fine as well. All right. Okay. And really kind of the last question that I wanted to focus on, because a lot of people struggle with these, are the ellipses, circles, hyperbolas. Let's do a hyperbola one. Let's say I want the center, vertices, and equations of the asymptotes for the following equation. And I say that, let's say, x squared divided by 25 minus y squared divided by 4 equals 1. This is a classic example of a hyperbola. The reason why you know it's a hyperbola is because there is a minus sign in the middle. If this were a plus sign, it would be an ellipse. Just to remind you again, hopefully you saw these lessons. If you didn't, if you have something like this, an ellipse is kind of an off-center circle, like an oval. Like an ellipse looks something like this. A hyperbola, on the other hand, is where there are two half circles and they face each other. It can look like this, or it can look like this. How do we know which one it is? Well, simple. If the x is first, then the hyperbola is going to cross the x-axis and look something like this. Whereas if the y is first, then they are going to cross the y-axis, and they're going to look like this. I can explain why. I mean, the short reason why is that that in a case like this, where x is first, x can never be 0. Think about it. If x is 0, then you can't have 0 minus something be 1. Remember, this is a squared term, so it has to be a positive term. You can't have 0 minus a positive number equaling 1. So x can never be 0. So if x is first, x can never be 0. So therefore, it can't cross the y-axis. Remember, x is 0 over here. And if y is first, then for the same reason, y can never equal 0. So in this case, the hyperbola is going to look something like this in this example. The center, if the terms are just simply x and y, the center is 0 and 0. Or if the equation looked like this, x minus 3 squared, then over 5, whatever, plus or minus makes no difference, y plus 2 squared over 10, then the center would be whatever the negative value over here. Instead of negative 3, it would be 3, and the y value would be whatever the negative over here is, which would be 2. But over here, the center is 0 and 0. The vertices, which means how spread out they are from the center, are simply the square root of whatever's over here. The vertices are the square root of 25, which is 5, which means they're 5 away from the center. So let's draw a graph over here. All right. So for this equation, they're going to, the x is first, so it's going to look something like this. The graph is going to look something like this. How far away are they from the center? The origin is over here, which is 0, 0. And the answer is they're 5 away. It's whatever the square root of this is, which means if we go 1, 2, 3, 4, 5, that's going to be one vertices, whatever. And the other one will be over here, which means the vertices will be 5 and 0, and the other one will be -5 and 0. Now, the equations of the asymptotes are a little bit more complex. The equations of the asymptotes are y equals negative, or really plus or minus, b over a times x. b is whatever the square root of this is, and a is whatever the square root of that is. So b over here in this case would be the square root of 4, and a would be the square root of 25. I obviously gave you ones that are perfect squares. So b would be 2, this would be 5, and so the answer would be y equals plus or minus b, which is 5, over a, which b, which is 2, over a, which is 5, times x, which means our two equations are y equals positive 2/5 x and y equals negative 2/5 x. Those are the two equations of our asymptotes. Now, the asymptotes are what they are lines. Again, I didn't draw this very precisely, but they're lines that the hyperbola approaches but never actually touches. If you graph them, you would see it. If you graph them more precisely, you would see it more clearly, but that's the way to figure out the equations of the asymptotes. Obviously, there are some practice questions in the homework, but you probably are going to see a question. Not every exam version, but most exam versions have, one question on that. And they're not that complex, but I see people leave it blank probably simply because they gave up on it for whatever reason. All right, so that is pretty much what I wanted to cover today. It's about an hour at this point. Does anybody have any questions that they would like me to go over? You can type them into the chat window if you do.